Okay, good afternoon, grade 9. We are now in the middle of the discussion. Since your um, fourth mastery test is fast approaching, we uh, we might skip some of these examples simply because we're running out of time. And by next meeting, hopefully, we can have the review, right? The higher the machine's efficiency, the greater the amount of heat is converted into useful mechanical work. Devices with higher efficiency requires less energy to operate. Let's continue. The first law again of thermodynamics states that when the heat is added up to the system does the external work and its internal energy increases. This is why no engine in existence works 100% efficiency. So, again, as what I had told you last meeting, that energy based on thermodynamics is neither created nor destroyed. Okay? But we can transform energy from one form to another. So that is why there is no such thing as 100% efficiency when it comes to work. Okay? Heat engine technologies. Heat engines had known as early as 16th century but has been made into increasing useful devices only during the 17th century. Why? When inventors acquired a better understanding of the processes involved, they are continually being developed today. Here are some of the technological application of heat engines. Okay. Remember the let me tell you this. Remember the Titanic?
Yes, sir.
Okay. Titanic actually uses thermal or heat engine. Okay. We usually call that as thermal engine. Okay. In their thermal engine, you
Like
can see that there is
in the kwan, sir, trains, they
yeah,
use heat.
they use heat. That is actually between the 17th century. Okay. They use heat in order for the machine to operate. At the same time, they have heat chambers, okay, with employees downstairs. So if you're going to look at the component of Titanic, in the lower part, you can see a lot of employees actually in the burning chamber just to produce heat. Okay. That is again that is in the middle of the 17th century. Geothermal power plants. Okay. Geothermal power plants work under the principle of heat engines. Yes, correct. It uses energy in the form of the Earth's natural heat in producing electricity to power up houses and industries. How would that be possible? Let's check it out. This is how the geothermal power plant operates using the principle of heat engine. Power plant digs deep into Earth's surface where the temperature increases with the depth and where hot water can be found. You remember that these areas here are considered as with a lot of pressure, okay, because hot water can be found there, and this water um, are actually looking for an exit, right? This hot water is pumped to the well under high pressure until it reaches the surface of the earth, where pressure then lowered, allowing water to turn into steam. Okay, this steam makes a turbine rotate, okay, thereby allowing the generator to produce electricity. A steam turbine is a device that allows steam to do mechanical work on the generator. Okay? A generator, on the other hand, is a device that converts mechanical work into electricity. The cooling towers converts the steam back into the water to low temperature surroundings. So meaning to say, it actually has a pattern or a cycle. Okay? From the hot water, we're going to look at the illustration. Can you see the illustration now?
Yes, sir.
Okay. Okay. From the hot water, if they are actually um, get in touch with this, they have already the sources. They gather all the hot water going to the steam chamber. And This steam is accumulated in the steam chamber, going to now to the turbine. The turbine generates, the turbine now rotates, turning on to the steam, and the turbine enables the generator to generate electricity, and so on. So after which, the water is being transferred to the cooling tower and injected back to the surface of the earth. So the cycle repeats again and again. That's how geothermal power plant works. Four-stroke engine. Okay, four-stroke engine. When a mixture of air. By the way, these are the common engines used by your cars. Okay, when a mixture of air and fuel enters the cylinder through the intake valve, the cylinder compresses air-fuel mixture. The compression pushes the spark or the spark plug, which causes gas to ignite and producing heat. Once the piston hits the button, the exhaust valve opens, and the burnt fuel mixture expelled through the exhaust valve as the piston returns back. Just the 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 exhaust valve there actually um, emits smoke going to your exhaust manifold. This is now the pattern. Okay, this is your engine inside your engine. This what would look like inside your engine. Um, if you're going to dissect it, and the motion also of your engine. So most probably they open the chamber. These are the bulbs, intake and exhaust bulbs, and then the spark plug. So the fuel and the air actually mix in order for the combustion to take place. What are the component of heat, or shall we say fire? We have, it is a triangle. Okay? We need oxygen or air. We need also fuel, and we need what? Heat. Okay. Actually, it is present there, and once heat is generated, therefore there is a mechanical work happening. Okay. There is a compression in the combustion chamber. There's also burning of the gases because the spark plug is doing the heat, or is doing something for this fuel to be combusted. Do you have any question?
No, sir.
Okay. In the exhaust, the gas there is emitted through the exhaust manifold and exits in your tambucho. Okay, that's the exhaust manifold. This process causes mechanical work to be done on the vehicle's drive shaft and into the wheels, thus causing the car to move. So you are now converting energy from heat energy to mechanical energy or mechanical work. Okay? The exhaust gas is pushed out by the piston is that has not been converted into useful mechanical work. It comes out in the vehicle's mufflers or tambucho. So it's not 100% converted into mechanical work simply because some of them are converted into smoke, okay, air, okay, and this is why, according to thermodynamics, that there is no such thing as 100% mechanical work when it comes to engines. Electricity. Margie, are you still with us?
Yes, sir.
Right. Electricity, there are several ways in generating electrical energy, but the principle they follow is just the same: energy transformation. Renewable energy comes from the sources that are naturally replaced over a short period of time. If it is renewable, it can be replaced in a shorter or short period of time, just like your um, wind energy or your thermal energy. This could be replaced over a period of time or a short period of time. On the other hand, non-renewable sources can only be replaced over a long period of time, just like your coal, your oil. This can be replaced over a long period of time. We cannot just create oil. in just a matter of short period. It is a matter of hundreds of years, or thousands of years, or even billions of years. Coal, natural gas, and nuclear energy power plants are non-renewable sources of energy. Hydroelectric, wind, and biomass power plants are renewable energy sources because we can just replace them in a shorter period of time. Except for nuclear energy, the Philippines make use of these renewable and non-renewable energy sources. Yes. Before we have a power plant in Bataan. It's a nuclear power plant, but it was closed because there are some harmful effects of this into humanity, and it can cause serious damages, like for example cancer. Do you have any question?
No, sir.
Hydroelectric power. Okay. The primary component of a hydroelectric power plant are the dam, which considered as your storage of water, intake, turbine, generator, transformer, power lines, and the outflow. So a dam is usually built in a river collecting water in the reservoir. The water height of elevation is important because the higher the elevation, the greater is the stored energy. Okay, remember that there is a pull of gravity or gravitational pull. So this will help you out with in collecting water in the reservoir. During the intake process, gates in the dam are open, letting water enters in a narrow pipeline called the penstock. Since penstock is narrow, the water builds up pressure, causing the blades of the turbine to rotate. Okay? Once the turbine is connected to a generator to a shaft. As the turbine rotates, or once the turbine rotates, magnets that are within the coils of the wire in the generator also rotate. This process produces current, okay? Thereby converting mechanical energy into electrical energy. We actually tried this one when I was still in high school, I think. I converted a simple dynamo. Are you familiar with the dynamo?
No, sir.
It's a small motor. It is powered by a battery. Okay, this
Uh,
usually used in your electric fan, the hand fan powered by battery. Are you familiar with that?
yes, sir.
Okay, these are also used by cars, no? Katong mga duwaan na car, you can see a lot of these, no? This is a simple motor. So I tried, instead of having it rotated using a battery, I tried rotating it faster so that I might have an accumulation of energy or power. So upon checking, yes, I tried rotating it faster. I did use a um, different machine in order to rotate it more faster. And yes, I generated electricity out of it. So I actually gathered or turned on an LED, no, because of those. So there is, yes, this is one of the greatest achievement in science with regards to converting energy. No? And turbine is an example of a motor machine. So it converts now this the flow of water through the shaft into a current with the help of the generator. Let's move forward. Electrical current is converted into a transformer in a high voltage current before it is transmitted in a long distance through power lines. Okay, it should be converted into high voltage current. Why? Because it needs to travel far in order to get into the power lines and into the houses. So it needs a high voltage current in order to travel in a far line to reach, okay, the houses. Okay. In common type of hydroelectric power plant, the water moves to the river downstream during the outflow process. So it will just return on the river through the outflow process. Sure, what will happen if it if the transformer didn't convert it into high voltage? Simple, it cannot reach in the power lines. Aside from that, it might have a loss of energy, lost in the process. Remember that these are converted into another form of energy, like for example, heat energy. It will just return to heat. Okay. And what will happen if this high voltage will not be lowered in the houses? Simple. We will not receiving the exact amount of 22 volts or 220 volts. Higher than that can damage the electrical devices. So it might damage all the devices at home. Okay, let's move forward. So this is now the movement of your hydroelectric power plant. Okay, so this is the intake. If you're going to look at intake, penstock, and the turbine actually generates there. Okay, going to the generator, and the water just go to the outflow. Okay, the generator generates electricity going to the transformer. The transformer now gives a high voltage towards the power lines or pipelines. And then the cycle repeats again and again. Okay, can you see the illustration?
Yes, sir.
Okay. A pump storage plant is another type of hydroelectric power plant. Okay, it has two reservoirs, the high reservoir and the low reservoir. Water from the high reservoir is used to generate electricity, and use water goes to the low reservoir which the turbine is installed. Okay? Instead of allowing water to go to the downstream, the turbine pumps water back to the high reservoir, making the water available again for electric generation. So this is the second type. So instead of going to the outflow, they tend to recycle the water back again to the high reservoir. Okay? Making water available again for electricity generation. So that's a um good innovation actually. But you still need to have a generator, or you still need to have a turbine in the lower or in the lower reservoir in order to transfer your water back to the higher reservoir. Correct? A water pump, for example. Wind power. A wind power plant has these main components. We have the rotor blades, important, the tower, shaft, and the generator. The rotor blades are mounted in the tower that can be as high as 30 meters or more. At this height, wind moves faster and is less turbulent. Okay? When wind blows, the rotor blades rotate. These blades are connected to a generator through a shaft. The generator converts the blade's mechanical energy into electrical energy. Okay, remember again that your generator actually connected to the blades. Now once the blades rotate, okay, the generator also generates electrical energy or electricity. Wind turbine has anemometer, an instrument that measures wind speed. A controller starts up the machine at wind speed for about 13 kilometers per hour to 26 kilometers per hour, and shuts off at the wind speed of about 89 kilometers per hour. Why do we need to shut it down or shut it off at the wind speed of 89 kilometers per hour? What do you think so? Is the reason?
Again, sir?
What do you think is the reason why we need to shut off um, the wind turbine if the speed reaches for about 89 kilometers per hour.
It would go out of control.
Yes, correct. It could go out of control. Correct. It can actually damage the turbine because it generates a lot of energy. Remember, once energy is generated, heat also is generated. So you might burn your wind turbine. Correct. It should be shut down. This shutting off is necessary to prevent damage to the machine at a very high wind speeds. During emergencies, the brake stops the rotor, either mechanically, electrically, or hydraulically. Hydraulics. Okay? This is to prevent further damage. The rotor is directly connected to a low-speed shaft, which is also connected to the gearbox with the high-speed shaft. The gearbox increases the rotational speed to the required rotational speed, which is 1,000 to 1,800 rotation per minute or RPM. Okay. To make the generator produce electricity, it should rotate faster to create electricity. Okay. This is now the component of your wind generators or wind power plants. Okay. This is your blades. Okay. This is your rotor, the gearbox, the generator, anemometer, okay, high speed shaft, and actually it has a brake here. So it will just activate the brake if the speed reaches for about 89 kilometers per hour. Do you have questions so far?
Hmm. No, sir.
Right? Let's move now to biomass. Okay. Biomass comes from the organic materials, which contain stored energy in the form of chemical energy. These materials include plant and animal wastes, which release energy when it burns or decomposes. Remains of dead plant and trees, such as branches, bark, wood, chips, and sawdusts from lumber mills, are sources of biomass. Okay? The stored energy from these materials can be converted into other forms. Again, the law of thermodynamics. Biomass materials are fed into furnace, where these materials are burned. The heat produced in the process turns water into steam. The steam makes the turbine rotate and convert mechanical energy into electrical energy again. So, this is a matter of, by the way, um, have you tried asking how this come up in the mind of the inventors, or in the mind of the people? Simply because they tend to find alternatives for these energies. Remember that talking about scarcity of electricity, there are a lot of areas in our country, for example, that has a lot of problem with electricity. So that is why human as we are, we tend to look for another alternative in order for us to answer the primary problem in our area. So these are the answers. Electrical energy transmission and distribution. After electrical energy is produced by power plants, it is transmitted over a long distance to be distributed in different industries and homes. A transformer is a device that transfers electrical energy from and among circuits with changes in the voltage. Remember that voltage pushes electrons around the circuit. Okay? Generators produce electricity at a high voltage or about 25,000 volts. Okay? A transformer steps up the voltage even higher to 400,000 volts. This stepping up of voltage is necessary, just what I had told you a while ago, to transmit electricity efficiently or to prevent power loss. Because lower than that can actually have a power loss. It will just convert it into heat. Okay? Again, a transformer steps up the voltage, if even higher into 400 volts. This is necessary to prevent power loss, right? Because this travels in a long, long, long way. Okay? If you're going to look at the illustration, from the power plant, it generates electricity, and the transformer steps up the voltage for transmission going to the transmission lines. Okay? And it steps down the voltage with the use of transformer again going to the houses. The transformer that you can see in your posts in your area, those are the step down transformer. Kanang nasa poste, those are step down. Okay? Kanang nasa VECO, if you're going to look at in the area, in the VECO and Sibeco, they have you have a lot of transformers there. The step up transformer. So those are just for stepping up or pump more voltage or higher than 400,000 volts in order for the transmission to be effective. Again, lower than that can cause electricity loss or energy loss. Okay. Again, if there is no transformer for stepping down, tendency is all your devices at home will be damaged because that is higher than the needed voltage of your devices. In the Philippines, we're using 220 volts. In Japan and other areas, they're using 110. Okay? Are you still with me? Are you still with me? MD and Margie?
Yes, sir.
Okay. We come up with this discussion. I discuss this plainly without illustrations or without examples as of the moment simply because your fourth mastery test is fast approaching and we need to take this up. By the way, the coverage for your fourth mastery test is only this. Okay? And talking about,
Heat,
yes,
sir. Only heat.
heat, work, efficiency, and electricity. These are the coverage. Sure. What are the content of the exam? The content of the exam are simply the basics. Okay? The content of the exam are those discussed in the module or the concepts. You even have the concept analysis in your exam. So you need to analyze the concepts behind and how heat is generated or how work related to heat. Those are just the concept. Okay? You need to analyze and how efficiency is related to heat and work. Right? Do you have any questions so far with the discussed topic?
No, sir.
Okay. If you have question, again, Margie and MD, please raise it in our GC or you can directly ask me through a private message. Right?
Yes, sir.
Okay, class. I think that will be all for today, grade 9. Thank you for your participation. Hopefully, we can have the review. Let me check. Um, our next discussion, let me check on the
Mm.
schedule. Our next discussion is this Wednesday. Hopefully, by Wednesday, we can have a review. We'll let you know the pattern of the exam. At the same time, what could be the concepts behind those exam or those part of the exam, right?
Yes, sir.
I think that will be for today, class. Thank you for your participation. As usual, MD and Margie. Have a nice day, grade 9. Goodbye.
Thank you, sir.